Assalamu alaikum wa rahmatullahi wa barakatuh. This is the second video in Chapter 4, Mechanical Oscillations. At the end of this video, you are going to be able to establish the differential equation which governs the simple harmonic motion of a horizontal elastic pendulum. Before we start, let's remember what we took in the last video, video number 1. We said that mechanical oscillations can be free, driven, or forced. Free mechanical oscillations can be damped or undamped. Finally, we said that an oscillation is characterized by its period, its frequency, and its amplitude. To study the free undamped oscillations, we're going to ask first some questions like, what is a simple harmonic motion? How should we determine the differential equation? And what is its time equation of motion? We're going to start first by defining the differential equation. The main question that you are asking is, what is a differential equation? How mathematics can help us? In mathematics, differential equation is an equation that connects an origin function x or more to their derivatives like x prime, x double prime, etc. I will give you some examples of differential equations, like ax prime plus bx equals to c, where here we have the origin function x and its derivative x prime, and because we have the first derivative only in this equation, so we call it first order differential equation. Another example, ax double prime plus bx prime plus cx equals to d, and here we have in the same equation x, the origin function, its derivatives x prime and x double prime. Because we have the second derivative, so we call it second order differential equation. Besides, we are going to deal with this special case where a positive constant is multiplied with the origin function x. For example, if I have this differential equation x double prime minus 2x equals to 0, here we find that minus is multiplied by omega 0 squared, so the coefficient of x is negative. This is not the case that we are going to study. Second example, x double prime plus 4x equals to 0. Plus 4 is plus omega 0 squared in our situation, so it is positive coefficient for x, then this is the case that we are going to study. Now the second question that you may ask is, how this differential equation can help us in studying motion? Actually, this differential equation has a solution, and this solution is of the form either x equals a sine omega 0 t plus phi, or x equals to a cosine omega 0 t plus phi, where a, omega 0, phi, and phi are constants. A can be positive or negative. This solution is called the time equation of motion, where x is a function of time. This time equation is completely new to you, and we are going to explain it for you. But first, how do we verify that this equation is a solution to the differential equation that we gave you? You know, we should replace it in the differential equation, and this equality should be verified. First, to make this step, we're going to consider x equals to a cosine omega 0 t plus phi, and the same study can be done for x equals to a sine omega 0 t plus phi. We are going to use these two rules to make our verification, which are the derivative of sine u, where u is a function of time, is the derivative of u times cosine u, where the derivative of cosine u, where u is a function of time, is minus the derivative of u times sine u. First, let's find the derivative x double prime of x and replace it in the equation. X equals to a cosine omega 0 t plus phi. To make the derivative of x double prime, we have two steps. First, we're going to find x prime, and then we're going to find x double prime, and always following the two rules of sine u prime and cosine u prime. So in this equation, we have omega 0 t plus phi is the function u of t. What is the derivative of u of t? In this case, it is a function of a t plus phi, where phi is constant, as we said before, omega 0 is constant, then the derivative of omega 0 t plus phi is just omega 0. Now, x prime is minus omega 0 into a sine omega 0 t plus phi. First, the derivative of x is minus, because we are making derivative of cosine, so minus omega 0, which is the derivative of the function omega 0 t plus phi, into a sine omega 0 t plus phi, where a is constant, so we write it as it is. Now the derivative of x prime is minus omega 0, which is constant, into, now the derivative of a sine omega 0 t plus phi is omega 0 again, because we are making derivative of u prime of t, which is omega 0 t plus phi. So omega 0 times a cosine omega 0 t plus phi, because the derivative of sine is cosine. Finally, the answer is minus omega 0 squared a cosine omega 0 t plus phi. The second step now is to replace x and x double prime in the differential equation. So x double prime plus omega 0 tx equals to 0. X double prime is minus a omega 0 squared cosine omega 0 t plus phi plus omega 0 squared, it is the same, then a cosine omega 0 t plus phi, it's the function x, equals to 0. Now take common a cosine omega 0 t plus phi. What happens? We have minus omega 0 squared plus omega 0 squared, which is 0. And in this case, we say that it is verified, and a cosine omega 0 t plus phi is a solution for the differential equation. Now it's your turn to try to use the same verification for x equals a sine omega 0 t plus phi. It's okay that we have verified that this is a solution, but how can we understand this new time equation? First, we should recognize that omega 0 t plus phi represents the angle for cosine in this equation, and remember that cosine varies between -1 and +1, where alpha lies between 0 and 2k pi. Then, in this case, a cosine omega 0 t plus phi, which is x, should lie between minus the absolute of a and plus the absolute of a. After that, we should try to draw it and deduce its characteristics. We are going to take, for an example, the simple equation x equals 2 sine alpha, and try to draw it. We are going then to fill in a table with successive values of alpha and x, and place the points directly on a graph paper. You can help me with the calculations to check the answers. Let's start. For alpha is 0, x is 0 since 2 sine 0 is 0, and we place the point. For alpha equals to pi over 4, the answer is radical 2. Approximately it's 1.4. Then pi over 2, it's exactly 2, because sine pi over 2 is 1. 3 pi over 4, it's radical 2, pi 0. 5 pi over 4 minus radical 2, 3 pi over 2, it's minus 2, 7 pi over 4, it's minus radical 2, then 2 pi, it's 0. After that, we find that the points are repetitive. You can try to take different values and check them on the figure and see what is the result then. Oh, it is a sinusoidal shape. First note, it's clear that this shape is periodic because it is repeating itself each time. In this case, it is 2 pi. Then, a sine function is periodic. Then, the amplitude is constant and equals to the absolute of the coefficient of sine. Here, the coefficient is already positive. Keeping in mind that alpha is omega 0 t plus phi and always in radians, we deduce that a motion of time equation of the form x equals to a cosine omega 0 t plus phi or a sine omega 0 t plus phi is called simple harmonic motion. A free undamped mechanical oscillation then is a simple harmonic motion. It is important then to know that to define the nature of motion, we say it is a simple harmonic motion if the differential equation has the form x double prime plus omega 0 t x equals to 0, or even if the time equation is given as a cosine omega 0 t plus phi or a sine omega 0 t plus phi. But if they asked about the type of oscillations, so the answer should be all the time free undamped mechanical oscillation in this situation. It is enough for this video. In the next video, we are going to define more the simple harmonic motion and define its characteristics. To sum up what we have taken till now, we said that we have mechanical oscillations and they can be free, driven, forced. These oscillations can be damped or undamped, and they are characterized by period, frequency, amplitude. The nature of the oscillations made by an undamped oscillator is simple harmonic, and the differential equation is given by x double prime plus omega 0 squared x equals to 0, where the time equation is given by x equals to a sine or cosine omega 0 t plus phi. This is the end of the second part. Thank you for your attention.